So today we're going to look at and talk a little bit about density and volume. So to put these into definition, they sound really similar, but they are different. For volume, we're talking about the amount of space the matter of an object takes up. The matter of an object takes up. For density, now this is going to sound a lot alike, but again, it is different. Density is the amount of mass in a certain volume of matter. So this is the amount of mass in a certain volume of matter. Okay? So what this means is that we can have things that are the same volume even if they have different masses. So that's really what we're calculating when we're looking at density versus volume. For volume specifically, we can have a few different common units going on here. So for volume, we measure in liters, which is our big L, milliliters, which is our small m, big L, or, and this might sound like a weird one to us, cubic centimeters. So this is small c, small m with a 3 above the m. Now, normally with rectangular objects, we can calculate the volume pretty easily just by multiplying the length with height altogether. So, for example, if we were looking at, let's say, a Lego block. Let's say that we have a giant Lego block and it is 50 centimeters in length. So that would be down here. This is our length, 50 centimeters. We have a height of 10 centimeters, let's say, and then a width. So that would be like if I drew this as an intended block, kind of a rough sketch here. Here we go. That would be here. That would be 8 centimeters. So then all we would have to do is multiply again that length, so that 50 centimeters, times our height, which is 10 centimeters, and then times our width, which is 8 centimeters. So we have length times height times width. If we put this into our calculator and calculated it all together, we would get a total of 4,000. Now, this is where that weird unit comes in. So I said that we could measure volume in what's called cubic centimeters. And this is why. Here, if we look, we have 1, 2, 3 centimeter units. If we multiply those together, we have cm to the third, right? So then we would have for our units 4,000 cubic centimeters. And that would be our answer for our volume. So what happens if the object is really weird? Like instead of a nice little Lego block, we have like Lego Batman or Lego Pikachu. In that case, we can use a graduated cylinder, wow, words are hard, a graduated cylinder, and submerge the object into that graduated cylinder filled with water. This allows us to find the volume of the object in milliliters rather than cubic centimeters. So let's take a look at that. So let's say, again, that we do have that, we'll say Lego Pikachu. I'm feeling Pokemon. So let's say we have a Lego Pikachu, okay? So if you take the mass reading of the Lego Pikachu before submerging it in the water, we can easily also calculate the density of the Lego Pikachu. So let's see what that looks like. Let's say we have our little graduated cylinder here. Okay, and then we have our Lego Pikachu. We're gonna have no judgments here. Our little Lego Pikachu, okay? And we put our Lego Pikachu into the water and we see how much that water rose. So it could be maybe the water was like here to begin with, and then it ended up here, okay? So that means that we have a volume reading for this Lego Pikachu of 10 milliliters. 10 milliliters. So that is our volume. So if we just needed to find out the volume, we have it. Now let's say that we want to find the density, okay? So our density equation is actually going to be D equals M over V. D is density, M is going to be mass, and then V is going to be volume. So here we already have our volume, so that's one check. Now, like I said earlier, what you could do is that before submerging the Lego Pikachu, you could take a scale and weigh out our Lego Pikachu first. So taking the mass reading here of our Lego Pikachu. Now let's say that this was, I don't know, 5 grams. That's how much mass our Lego Pikachu was. Okay, so then if we wanted to find the density of our Lego Pikachu, what we would do is we would do density equals 5 grams divided by, because that is our mass, divided by our volume, which is 10 milliliters. If we put this into the calculator, we will see that this is 0.5. And then we have to take our units here. Now, density, we're going to have both our mass and volume units at the end. So that would be grams over milliliters, and that would be our density units. And that would be our answer. Okay, so let's look at another example. So let's say that we also have a Lego Jigglypuff. Lego Jigglypuff. There we go. And we're going to calculate the density of that. So again, I'm just going to write my density equation up here. D equals M over V. Now, if we, just one quick side note, if we ever need to actually find a different variable that's not density, what we could do, and one way that I really love, is through the equation triangle. So the equation triangle works with any 3 variable equation, like our density equation. And all you have to do is put your variables as they are in your equation. So here I have a division equation. So I'm going to put M over V. So if it's on top of each other, that is division. If it's next to each other, that's multiplication. And then I just put the D in the free spot. So now I know let's say I need to calculate mass, all I would do is cover up mass and see that mass equals D multiplied by V. So mass equals D times V. Same thing here. If I need to find volume, I can see that mass is divided by density. So then I do volume equals mass divided by density. So that's just a little helpful way that we can kind of keep track of what we're calculating when it comes to density. So back to the Lego Jigglypuff. Let's say that we took a mass measurement of our Jigglypuff and we got 35 grams. 35 grams. And then we also, all right, so we have the mass of 35 grams. Let's say that we also took a volume reading and we got 125 milliliters. Now, something that I didn't say previously, milliliters are actually comparable to cubic centimeters. So that means that if we're looking at the measurement, if we have 1 milliliter, we also have 1 cubic centimeter. So if you ever see something written in cubic centimeters and you need to convert it to milliliters, just know that they are the exact same. So here, let's put this into our equation. We're finding density. So we're going to do our 35 grams divided by 125 milliliters. And if I put this into my calculator, I would see that density for my Lego Jigglypuff would be 0.28. And then again, I'm going to have grams over milliliters. And that's how you find our density. There you go. Hope this helped to define volume and density for you. Thanks for watching. If you found this helpful, check out any of my other videos and comment below if you have any questions.